2.4 Application of differentiation. This is roller coaster. When you inside, what you feel? We feel up and down and very exciting, right? The building of a roller coaster not only takes safety into consideration but also uses maximum enjoyment out of the ride. Each point on the track is specially designed to achieve these objectives. So each point is actually has a different gradient. Okay, which technique do we need to in order to determine the gradient at each of the points along the track of this roller coaster? Okay, let's see. This is the curve. The pink color is a curve. And a curve, we say it is a y equals to x squared. After we differentiate, we get 2x. Okay, so the function of, after we differentiate this function, we call function of gradient. This is gradient function. This is a curve function. And the gradient function is different gradient on each point on the curve. Okay, so let's see, for example, when this function x squared, after you differentiate, you get 2x. So after differentiate is f prime. And at each point, there's different gradient. Okay, for example, when x equals to negative 2 here, the gradient is negative 4. When x equals to negative 1, the gradient is negative 2. Why I say gradient? Because f prime. When x equals to 0, the gradient equals 0. When x equals to 1, the gradient equals to 2. When x equals to 2, gradient equals to 4. So this is the gradient at each different point. Okay, so the gradient of the tangent, okay, when this is a curve, this is a gradient. The gradient, if gradient less than 0, is going down. If it's a horizontal, is equals to 0. When you see the blue color, when the gradient is more than 0, is going up. Okay? Alright. Let's see example 13. The diagram on the right show a part of the curve. This is a curve. And a point A, point B, point C. Find an expression for dy dx, meaning you find dy dx only. Okay, then number 2, the gradient of the tangent to the curve at point A, point B, point C. So each point with different gradient. For each of the following A, B, C, state the condition of the gradient of the tangent to the curve. Okay, let's see example A. This is a function and y equals to 2x plus x power negative 2. Easier for us to do differentiation. When we divide dx equals to 2 plus, this one negative 2 go in front, 2. Okay, x power negative 2 minus 1, negative 3. And this is the gradient function. We know we call gradient function. Okay, done. Expression A. B, A2. Gradient of the tangent. Now the question asking the gradient. Gradient means the answer in a number. What is a gradient? Kecerunan dia. Okay, at the to the tangent to the curve A. Curve A, you see the point 1 over 2 and 5. Then we consider the x. We take the x only because here only x, right? So you substitute the x inside, then you get negative 14. Point B also we take 1. We take the point x. We substitute inside the gradient function. We will get 0. Point C, we take the 2. The x equals to 2, we substitute inside here, we get this number. So 1, 2, 3 get. For each of the point ABC, state the condition. What is the condition? This is less than 0. The gradient less than 0. So the gradient is negative. And when the gradient negative is slant to the left. When it's 0, it's horizontal. When it's more than 0, the gradient is positive. And the tangent slant to the right. Okay, finish. And you can do self-exercise 2.7 only 2 questions. Okay, let's see this. Give you example. Okay. Find the gradient of the tangent of the following curve at the given point A. This is the curve. The question asks you to find the gradient of the tangent. Okay, so you need to find the function first. Gradient function. dy dx. Okay, dy dx equals to 4x minus 5. Okay, 2 to 4, 4x minus 5. Now, when the question asks you to find gradient and given the point, so you need to use the point. we substitute the point x equals to -1, substitute inside here. When x equals to -1, dy dx equals to 4, you multiply -1 inside. Okay, -4, -5, -9. So now you already found the gradient function. Finish. Okay? So gradient function equals the gradient only. So now you already find the gradient of the tangent. This is gradient of the tangent. -9, done. Okay, next. The question asks you to find the equation. Okay? Equation of the tangent. Okay, this is the next part. The equation. Equation of the tangent and normal to the curve at point this. Right. Consider this is point P, R, P and R. When normally we find the gradient, we find the equation of the equation of a straight line, we have 2 points, we find the gradient. And we are using this formula. Remember last time, Form 4, you learned this formula. Y minus y1 equals to m bracket x minus x1. We are going to use this formula. Okay, this condition like this. This is the curve. After you find the gradient function, actually you find, okay, the gradient function and also you are given a point. So when you are finding the gradient function and at point A, so it's a straight line, the blue color one. And if the question asks you to find equation of normal, so is a green color one. Okay, the condition like this. So let's see example. Okay, give you the simple example first. This one. Okay. Find the equation of tangent. Okay, so I want equation now. Before this, I find gradient only. See, find what? Find gradient. Now I want to find equation. Equation of tangent. Equation of tangent, we use gradient of tangent. Gradient of tangent. This one, -9. Okay? So, equation, again, dy, actually we do this, I do again, okay, 4x minus 5. This is equation of tangent. And why we want to find this one? We find this one because equation of gradient. We want to find this because we want to find the gradient. Later, we want y minus y1 equals to m x minus x1. This is finding the equation. Okay, equation of tangent. When we are finding equation of tangent, we are using the gradient of tangent. Gradient of tangent, we substitute x equals to -1 and dy dx equals to, okay, equals to -9. This is gradient. So gradient now -9. And you are given the point, so we are using this point. Okay, now we can start to use the equation of tangent. Y minus y1. Okay, this is x1, this is y1. We substitute the value inside, this is m. Y1, 2, gradient, -9, x minus x1, minus x1, so now plus 1. So this is the equation. Okay, -9x minus 9 plus 2 minus 7. Okay, so this is like example 4. Find the equation of tangent and normal to this curve. Okay, so find the equation. We find already lah. Okay, then if I want to find this equation of tangent, done. If I want to find equation of normal, okay, it is like this is the curve. This is your y equals to fx. And just now we find the equation of tangent at this point. Okay, this is equation of tangent at this point. X equals to what? And now we want to find equation of normal. This is 90 degree here. Okay, so last time you learned about this one M1, this one M2. If M1 equals to negative 9, M2 will be equals to 1 over 9 because M1, M2 equals to negative 1. M1 negative 9, M2 you don't know, you negative 1. So this one will be 1 over 9. So in other words, if M1 equals to 2, your M2 equals to negative terbalik 1 over 2. If your M1 equals to 1 over 3, your M2 means the normal, it perpendicular to each other. M2 equals to positive become negative and then terbalik 3. If your M1 equals to negative 5, M2 equals to negative become positive and this one terbalik 1 over 5. Okay, so just turn it now. Equation of normal. So we want to find the equation, we must use y minus y1 equals to m x minus x1. And what you have, you must using the gradient, where gradient equals to what and point equals to what? Which point lah? Okay, gradient now. Equation of normal, we must use the gradient. This negative 9, right? And now the gradient will be if m1 equals to negative, if m1 equals to negative, the gradient of the tangent negative 9, so gradient of the normal will be 1 over 9. So now this gradient 1 over 9. Okay, so we just use a gradient. The special is here, gradient. All these are the same, exactly the same, especially this one, equation of normal. So from here, continue, equation of normal, equation of normal will be y minus y1. This is x1, this is y1. Y minus y1 equals to m. The gradient different. Just now the gradient here negative 9 because this is tangent. Now the gradient is 1 over 9 because this is equation normal. The difference is here only. X minus 1. Okay, so we can substitute 9y equals to 18 equals to x plus 1. 9y equals to x plus 1 plus 19. Okay, done. So let's see example in your textbook. Find the equation of tangent normal. Same, this is the function. So we differentiate this one, we get 3x squared minus 4x. Okay, this is equation of the gradient function at 0.25. So later we use the 2, we substitute inside. Okay, now when x equals to 2, we substitute inside, you get 4. Okay, the gradient of the tangent at this point is 4. Equation of tangent, y minus y1 equals to x equals to m, x minus x1. The m is 4 now. The other is the same. Finish. If gradient of the normal, exactly using the same function of gradient, okay, but the gradient now, you see here is 4, here is negative 1 over 4. And all these are the same, just the gradient different, negative 1 over 4 now. So this is the pink color, is a curve. The tangent at point when x equals to 2, this is the blue color. This is equation of tangent. And the green color is equation of normal. Okay, now you can do exercise 2.8.